So example 13 makes us look at the equation 3 times the square root of 2x plus 2 minus 2 times the square root of x plus 6 equals 0. Now I told you before that when we square multiple terms, we make more than that. So this side right now has 2 terms. If I squared that, I'm going to make at least 3, probably 4 terms. And that's just a nightmare. This side over here is 1 term. It'll just make 1. But it's 0. If I add something to 0, it's just what it is. So your first realization here is to move something over. I'm going to move this over because, I'm going to move the negative 2 times the square root of x plus 6 over. And I'm going to get 3 times the square root of 2x plus 2 equaling to 2 times the square root of x plus 6. Now, here, I have square roots on both sides. If I square each side, I'm still going to be left with 1 term. This is fantastic. But what you have to understand is that you're squaring the entire side. And that makes a big difference. A lot of people make a mistake here because what they do is they just attach the square to the square root. It actually goes to each part. The exponent goes to every factor. Anything multiplied, it goes to that. So what you're going to end up with when squaring these sides is 3 squared times the square root of 2x plus 2 squared. I'm just going to write this as 2x plus 2 because if we square a square root, we get rid of it. 2 squared is just 2 squared. And then the square root of x plus 6 squared makes x plus 6. Pretty simple. So now we have an equation we can work with. We're going to have 9 times 2x plus 2 equals 4 times x plus 6. We can further that and say this is 18x plus 18 equals 4x plus 24. Now, this is just linear, right? I can move things freely. I want to try to isolate my x's, and so I'm going to move my 4x over. I'm going to get 18x. Excuse me, that was wrong. It's going to be 14x. If you caught that, good for you. And then I'm going to move my 18 over. It's going to be minus 18. So I'm going to get 6 on the other side. So I'm going to get x to equal 6 over 14. Or really, x is going to equal, I can divide each of those by 2, it's going to equal 3/7. Now, I want to make sure that plugging 3/7 in is not going to break anything. So I go up to the top. I see that each one, if I plug 3/7 in, I get a positive number, right? 3/7 times 2 plus 2 is positive, 3/7 plus 6 is positive. This all works. And so, my answer is just simply 3/7. I finished it, and I've solved it.